You can start. Good evening. Good evening all. So today or this evening we'll be talking about redox reaction. For some it's the first time hearing this redox, but for others it's something they've heard repeatedly. Redox is otherwise still known as reduction oxidation reaction or oxidation reduction reaction. So today we'll be seeing what these reactions are. We'll see examples of these reactions, the definitions of these reactions, and we'll also be seeing some examples on how to work oxidation number. So moving directly, what are redox reactions? Redox reactions are types of reactions that involve both oxidation and reduction. That is, since we are getting the word there, oxidation, that means oxygen is involved. And then we'll now see what that reduction really is. So there are 5 definitions of oxidation reduction reaction. And these definitions are based on oxygen or additional removal of oxygen, removal or addition of hydrogen, um, addition or removal of electronegative elements, electron transfer, and oxidation number. So the first one, addition of oxygen. Oxidation in terms of addition of oxygen is when oxygen is added to a substance, while reduction is when oxygen is removed from a substance. Now, what do we mean? The example there, we have that of magnesium. When we burn magnesium in the presence of oxygen, which should be a form of combustion reaction, we see there that um, 2 molecules of magnesium react with oxygen, O2. Now, because of this reaction, oxygen now binds to magnesium. When this happens, it is oxidation. Why? Magnesium is being oxidized. Oxygen is added to magnesium. Now, same thing still occurs when we now do the reverse, passing hydrogen gas over heated copper. When we pass hydrogen gas over heated copper, the copper is CuO, copper oxide. Now, when we now pass hydrogen gas over this, the oxygen that is bound to the copper is removed. Now, because this oxygen has been removed, we can say the copper oxide has been reduced or has undergone reduction, just as the definition puts it. So if we have an equation of reaction where oxygen is added to a substance, that substance has been oxidized. But when we have a reaction whereby oxygen is removed or reduced, that substance has been reduced and we can say it has undergone reduction. So this is based on oxygen. I hope that is clear. Now, we notice what happens for that of copper. Because hydrogen gas comes into play, the hydrogen now binds or takes away the oxygen. That is why we can say reduction is what happened there. Now, we move to the next definition, hydrogen. For the case of hydrogen, oxidation is the removal of hydrogen from a substance, while reduction is the addition of hydrogen to a substance. So simply put, if we have a substance whereby hydrogen is removed, that substance has been oxidized. But if hydrogen is added, that substance has been reduced or has undergone reduction. Example there, we have decomposition of ammonia. Ammonia has 3 atoms of hydrogen bind to nitrogen. Now, in the case whereby ammonia undergoes decomposition, either thermal decomposition or catalytic, depending on the case or as the case may be, we now have nitrogen standing on its own and hydrogen standing on its own. When this happens, it means that oxidation has taken place. Why? Hydrogen has been removed from ammonia. So that is oxidation there. But in the case whereby these two now bind back together, that is nitrogen now reacting with hydrogen to form ammonia, because hydrogen is being added back to nitrogen, that is called reduction. I hope we understand it. Removal of hydrogen or decomposition of ammonia here is oxidation. But whereby hydrogen is added to a substance, it means it has undergone reduction. Now, that is a reverse with what happens in oxygen. For oxygen is added, that is oxidation. Where oxygen is removed, that is reduction. But for hydrogen, where hydrogen is added, it is reduction. Where hydrogen is removed, it is oxidation. Now, that will take us to next definition. Oxidation and reduction in terms of electronegative elements. Now, for the case of electronegative elements, oxidation will be the addition of an electronegative element to another element, while reduction is the removal of an electronegative element from a compound. Now, what are electronegative elements? All non-metals are electronegative. How do we mean by this? All metals or all elements that are from group 4 up to group 7 require some electrons to attain stability or to have 8 electrons in their outermost shell. Take, for example, chlorine. Chlorine has an atomic number of 17. So by electronic configuration, that will be 287. That means chlorine needs one more electron for it to attain to its octet configuration in that outermost shell. If we come back to say we'll come back to say nitrogen. Let's come back to nitrogen. Nitrogen has atomic number of 7. That means its electronic configuration is 2,5, meaning that nitrogen requires 3 electrons to attain its octet configuration. So all elements that require 3, 2, 1, even 4 in the case of silicon to attain that octet configuration are electronegative. So this shows the increase in electronegativity from phosphorus to carbon to sulfur to iodine, bromine, nitrogen, chlorine, oxygen, fluorine. So the most electronegative of these series is fluorine. Now, in metals, what we have is electropositivity, increasing electropositivity, because metals, that is group 1, group 2, group 3, can actually give out electrons from the outermost shell. So there we have potassium, sodium, calcium, magnesium, and the rest. So that shows increasing electropositivity from potassium to gold and silver, that's Ag and Au. Now, the point is this. Let's focus on the electronegative element. Where you add an electronegative element, any of these ones on top, to another element to form a compound, that is oxidation. But where you remove one of these electronegative elements, that is reduction. See example there. We have sodium, which is electropositive, reacting with chlorine, which is electronegative. When that happens, we have sodium chloride. So that reaction between sodium and chlorine, because chlorine is electronegative, addition of that electronegative element is oxidation. We're looking at the next one now. Ion, Fe, reacting with hydrogen chloride. Now, what happens in this equation of reaction is that hydrogen is removed, or we can say ion binds with chlorine. Chlorine has been removed from hydrogen. What does that tell us? That is reduction. That means hydrogen chloride has been what? Reduced. So where electronegative elements, chlorine and the others are removed from a reaction. The point is what? Is reduction. When they are added, for example, in the case of this sodium chloride, it is oxidation. I hope that is clear. Now, the next is for electron transfer. For electron transfer, the process whereby there is electron loss, that is removal of electron, it is oxidation. But where electron is gained, it is reduction. What do you mean by this? Magnesium has an atomic number of 12. Electronic configuration being 281. Sorry, 282. That tells us that the 2 there can be given off. So where magnesium gives off these 2 electrons, as we have in the equation of reaction, magnesium losing 2 electrons, magnesium will now have an ion number of +2, or yes, of +2. And that +2 there helps us know that it has been what? Oxidized. It has given up 2 electrons and it has been oxidized. I believe we explained this when we're talking about types of bonding, equivalent bond and covalent bond. Now, for equivalent bond, this is where something like this comes in. Giving out electron and you attain positivity. Now, because magnesium has given off 2 electrons, it becomes positively charged. And losing that electron makes it to be oxidized. Now, looking down, we have sulfur. Sulfur needs 2 electrons. It has atomic number of 16. So its electronic configuration is 286, meaning it needs 2 electrons in its outermost shell to attain octet configuration. That is, for it to have 8 in its outermost shell too. So when it accepts 2 electrons, say it accepts that 2 electrons from magnesium, it will become what? Negatively charged. Once it has accepted the electron and become negatively charged, it means it has been reduced. So that is based on loss of electron and gain of electron. Now, the other one is in terms of oxidation number. In terms of oxidation number, when there's increase in oxidation number, it means there is oxidation. While when there is decrease in oxidation number, it means there is reduction. So that helps us see that there is a very strong relationship between electron transfer and oxidation number. Now, the point is this, the oxidation number of an element is the charge on its atom or ion. For example, now, we have magnesium here. When magnesium loses 2 electrons, that means it has an oxidation number of what? +2, because it has given off 2 electrons. But if this magnesium was in its neutral state, as in just as a normal element, it will have an oxidation number of 0 because it's not giving off or it's not gaining. But the moment it has now given off that electron, or the moment an element has gained, it becomes either positively charged or negatively charged. Now, the number it now carries will now tell you the oxidation number of that element. So, example here is magnesium having 2+ because it has given off 2 electrons. Chlorine, when chlorine accepts an electron to become, to attain its octet configuration, chlorine, let's remember that chlorine has electronic configuration of 287 because it has atomic number of 17. Now, when it accepts 1 electron and becomes negatively charged, its oxidation number becomes -1, meaning it has what? Reduced, because it has gone from 0 to -1. Oxygen in its neutral state is 0, but the moment it accepts 2 electrons to become O2-, that will tell us that it now has an oxidation number of -2 and it has been what? Reduced. I hope that makes sense. Now, these are the 5 definitions of oxidation and reduction. Let me do a quick recap on these definitions. The 5 of the first one is based on oxygen, we have based on hydrogen, electronegative elements, electron transfer, and oxidation number. For oxygen, where oxygen is added to a compound or a substance, that substance has been oxidized. Where oxygen is removed, that substance has been reduced. For hydrogen, where hydrogen is added to a substance, that substance has been reduced. But where hydrogen is removed, that substance has been oxidized. For oxidation and reduction based on electronegative elements, where there is an addition of an electronegative element to another element, there has been what? Oxidation. But where there is removal of an electronegative element, there is reduction. For electron transfer, where there's electron loss, that substance has been oxidized. When there's electron gain, that substance has been reduced. Now, in the case of oxidation number, where there's an increase in oxidation number, that means that substance has been oxidized. Where there's a decrease in oxidation number, that substance has been reduced. Please, it's good we take note of all these definitions. They're very, very important. Now that moves us to some examples. Now, a substance that donates electron or gives off oxygen, let's put it that way, or gives off oxygen is an oxidizing agent. While a substance that accepts oxygen is a reducing agent. So if a substance is oxidized, that means that substance before then it was a reducing agent. But if a substance is reduced, that means it was an oxidizing agent. What do you mean by this? See the example, the first one, zinc. Under it, we have Ra, meaning reducing agent. Then plus CuSO4, which is the oxidizing agent. We notice that what happened to zinc? Zinc now accepts, or SO4 is now transferred to zinc because zinc now reacts with the SO4. So that means zinc has been what? Oxidized. But what is zinc? Is a reducing agent. Oxygen has now been added to zinc. That means zinc has been oxidized. But because it has been oxidized, it was a what? A reducing agent before. Now, what about the CuSO4? The CuSO4 was the one carrying the oxygen. And now, what happens? It loses that SO4 and is now standing on its own. So it has been what? Reduced. However, it is an oxidizing agent. Looking at the next example, we have magnesium reacting with hydrochloric acid. Now, what happens here? Magnesium here is a reducing agent, while hydrochloric acid is the oxidizing agent. What happens? Remember, this should now be based on that of electronegative element. Chlorine is electronegative. So because chlorine is now added to magnesium, that means magnesium has been oxidized. For that reason, magnesium is the reducing agent because it reduces hydrochloric acid. Now, because chlorine has been removed now from hydrochloric acid, that makes hydrochloric acid the oxidizing agent because it is what I was carrying the electronegative elements. So it is now reduced to what? Hydrogen. The next example, we have potassium bromide reacting with chlorine. Potassium bromide is the oxidizing agent, chlorine is the reducing agent. On the other side of the reaction, we see that what? Chlorine is now added to potassium. Now, what happens here? If we go back to that of electronegative element, looking at bromine and chlorine, bromine is more electronegative than chlorine. Do you see it? Sorry, increasing electropositivity. Sorry, electronegativity. Sorry, chlorine is more electronegative than bromine because we see that chlorine is in the front and bromine is behind. So now, because chlorine is more electronegative than bromine, it now what? Allow for bromine to be kicked off or for bromine to be removed. For that reason, that means what happens there? Potassium bromide has been reduced, while chlorine now become oxidized, or because chlorine now is the reducing agent, now oxidizes the potassium. So we have 2KCl and bromine. The final one there, we have potassium iodide reacting with bromine. What happens there? Bromine is still what? Removed and replaced with iodine. So let's get this straight. While we have oxidation and reduction, a substance that is oxidized is the reducing agent, while a substance that is reduced is the oxidizing agent. It's just that simple. Let me try to bring up a particular example. Say, for example, you and your friend, one person has 17 naira, the other person has 30 naira. Now, say that person that has 30 naira wants to buy something of 15 naira. That means the person needs 20 naira. For you to give the person 20 naira, that means, let's say you have you lent the person 20 naira, and that means the person has borrowed 20 naira from you. Because the person borrowed from you, the person has what? Reduced you. But you that you have given to that person, you have helped the person, and we can say you have what? Oxidized the person. I hope it makes sense. You have 17 naira, somebody has 30 naira. The person reduces your money from you. However, because you have given that person that 20 naira, you have helped the person, we can say you have been what? Oxidized. So that is how this reducing agent and oxidizing agent work. Elements that, or a compound that gives out this either electronegative element or gives out oxygen, giving out makes it to be reduced. However, it has oxidized the other party. That's the point there. So we now move to the rules for assigning oxidation number. We've talked about the oxidation number on the other side where we discussed the definition. So now, how are these oxidation numbers assigned? First rule is the oxidation number of an atom in an uncombined free element, whether monatomic, diatomic, polyatomic, is 0. That is, all elements in their natural state, as we see them in the periodic table, they have an oxidation number of 0. They are uncombined. So they have an oxidation number of 0. Now, what next one is the oxidation number of one oxygen atom is -2 in its compound, except in peroxide. What do you mean by this? Remember, oxygen needs 2 electrons for it to attain octet. So when it is in its combined state with other elements, say for example, there we have say for example H2O. Let's just bring that in, H2O. Now there, oxygen is O2 minus and needs 2 atoms or 2 electrons of hydrogen for there to be balanced in the reaction. So in that kind of case now, oxygen is O2 minus. However, in peroxide, as a hydrogen peroxide, sodium peroxide, and the others, it is not like that. There it is -1. And in binary compound, where it combines with fluorine directly, 1 atom of oxygen with 2 atoms of fluorine or chlorine. There in its binary compound, it is +2. But in other normal compounds where we can think of oxygen being there, it is -2. Carbon dioxide, there too is still the same thing. Now, another rule is this. The oxidation number of one hydrogen atom is +1 in its compound, except in hydrides of metals. Sodium hydride, there it is -1. So where it is in its hydride, it will be -1. Sodium hydride, potassium hydride, there it will also be -1. But in every other case, it is +1. Now, the next rule is Group 1, which are alkali metals, have oxidation number of +1. Group 2 have +2. Group 3 have +3 in all their compounds. When we check our periodic table, the first element down, we have lithium, sodium, potassium. All of them have +1 in their compound state. The ones in group 2, magnesium and calcium, +2. The ones in group 3, aluminium, and the others under, they are +3, including, yeah, that should be boron. Yeah, boron is the first member there. The aluminium too is there. So all of them, they are +3 in all their compounds. Those are the first of those. Now, other rules are halogens, which are group 7 elements, which includes fluorine, chlorine, bromine, which are, they are group 7, have -1 as the oxidation number for binary elements or binary compounds, except when they are bound to other more electronegative atoms. For example, where iodine, which is electronegative, still binds with fluorine, there it is +7. I hope we get it. There it is +7 because it's binding to a more electronegative um, element there. Another rule is the decision number of atoms in the monatomic ion is equal to the charge on it. Monatomic ions, only elements that can stand on their own. Sodium is one of them. Normal, the charge on it is +1, so it still retains its +1. Potassium is +2 monatomic. So these ones, they are monatomic and they still retain their normal number. That one is any complex ion. The sum of the decision number of all the atoms is equal to the charge on the ion. And any molecular compound, the sum of the total number is equal to 0. Now, what do you mean by this? Say you have a charged group, also called radical. I believe we talked about this before. For example, SO42 minus. The charge on top the SO42 minus, that 2 minus is the oxidation number. But when you have a normal compound, H2SO4, magnesium chloride, sodium chloride, the total oxidation number is equal to 0. As long as it's not charged, as long as it's not a radical, it is 0. So all compounds have a total oxidation number of 0. Why is this so? Because for it to have formed a compound, the charges on the electropositive elements have cancelled the charges on the electronegative elements. That is the only way you can have a balanced reaction. Now, how practical is this? Say, for example, let's talk about sulfuric acid, H2SO4, meaning it has 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. If the atom of hydrogen there, we remove 1 of it, that will be -1. That is the meaning. If one of the oxygen is removed, that will be -2, because oxygen there adds 2 to the entire thing. Or yes, adds 2 to the entire. So I hope we get to that. As long as it's a compound, for it to have stood as a compound, not a radical having a charge, it's all the charges have cancelled each other. That is why it will stand as 0. Now, let us see some examples of how to actually calculate this oxidation number, how to determine the oxidation number of a compound. The truth is that we might not always have all of these rules in our head, but some important rules there that we should always not forget is that, okay, all compounds have oxidation number of 0. If it is not charged, they are also 0. If the elements are not charged, it's also 0. Another one is having at the back of our mind that the oxidation number many times is based on the charge they could carry if they transfer electron or they accept electron. So, first example here, say we should calculate the oxidation number of sulfur in tetraoxosulfate 6 ion. Tetraoxosulfate 6 ion is SO42 minus. And they've given us obvious, like we said earlier, because it is charged, the charge it is carrying on top there is -2. So the question here is, what is the oxidation number of sulfur? That's what they're telling us to look for. Now, to solve that, we have oxidation number of sulfur, which is S that we are looking for, plus 4 times oxidation number of hydrogen. Why is it 4? Look at SO4. We see the 4 standing there. The 4 there is beside only oxygen. Hence, we use the 4 to multiply the oxidation number of oxygen. Why we are only putting oxidation number of S and not multiplying it with anything is because there is no visible number beside S. However, we do know that for an element to be standing, even though we are not seeing any number at all there, it means that is 1. So we have an invisible one close to oxidation number of S. So we are multiplying oxidation number of S times 1, and then oxidation number of oxygen times 4. Remember, all of this is equal to -2. Why? Because SO4 is carrying in charge of -2. Now, moving further, we have oxidation number of S will be equal to 6S plus 4 times 2x equals -2. What do we mean by this? Why are we bringing in the 6S? We have 6S there. Sorry about that. So, we are looking for S. That this is not supposed to be there. Sorry about that. We are looking for S. So now, what we have is, let's try to omit that 6 there, please. I would say this when I want to send it forward. The S there plus 4 into brackets X, 4 into brackets times -2. That will give us -8. 4 times -2 is -8. So S on the next line, -8 equals -2. Remember, the number that's outside. So if we collect like terms, S will be equal to -2. Taking 8 to the other side, 8 will now become plus. Now become +6. Let me take it again. We're looking for the oxidation number of S alone. For us to calculate this, what we do is we multiply the oxidation number of what you are looking for, the elements you are looking for, times the number of atoms of that element present in the compound. So there we have S has only one element here, so that's why I'm multiplying S times 1. Then oxidation number of oxygen is -2. So -2 times 4, which is there, equals to -8, as we have on the next line. We'll collect like terms, we'll now have it as +6. That's one example. This is another example here. Calculating the oxidation number of sulfur in K2SO4, only sulfur. Now, this is a compound, meaning that the oxidation number is what? 0. So we have K2SO4, all of this equals to 0. K is, well, we have the oxidation number of potassium is +1. Remember, based on periodic table. And there we have 2 atoms of potassium. Then we are still looking for sulfur. We are representing that is S, and only 1 atom of sulfur is there. So S times 1 still gives us S. Oxygen -2 times 4, which is the number of atoms of oxygen there, all equals to 0. So when we bring that together, we have 2 plus S plus -8 equals 0. S plus 2. Now the plus sign will remove because plus times minus is minus. So -8 equals 0. When we collect like terms, we have S equals 0 plus 8 going to the right side become +8. 2 going to the other side becomes -2. So S becomes what? +6. Now, notice that for this first question, we have S as +6. For this next question, we see as S as +6. So many at times, many of these elements stick to their particular oxidation number in their compounds and their radicals. So if on your head, you already have an idea of what the oxidation numbers are, when you calculate it, you would know what the answer will give you. And please, the sign is very, very important. Now, we talked about oxidizing and reducing agents. Yes. So now these are the definitions of oxidizing and reducing agent. An oxidizing agent or also a reducing agent, a reductant or reducer, is a substance that loses or donates electron. I remember I we said that. A reducing agent is a substance that loses or donates electron or gets oxidized, or whose oxidation number what increases. However, a reducing agent, or sorry, an oxidizing agent, an oxidant, an oxidizer is a substance that gains or accepts electron. But what happens? It can also what get reduced, or its oxidation number what decreases. So the reducing agent is the one that causes loss. The reducing agent causes loss of electron or donates electron. While the oxidation number, oxidizing agent is the one that does what? Gains. So that's that. Now, this is another example here. We have carbon, oxygen. Now, carbon there reacting with oxygen becomes CO2. Remember that carbon has atomic number of plus, or carbon needs 4 electrons. Carbon has a oxidation number of +4, while oxygen normally is -2. But because it is now 2 atoms of it here, it becomes what? -4. So +4 and -4 will give us what? 0. It cancels itself out. Yeah, next example there. Hydrogen reacting with copper oxide. Now, what happens is copper oxide is +2, oxygen is -2. Now we now have hydrogen reacting with oxygen. What happens there? It, excuse me, atoms of hydrogen. Now, because there will be 2 atoms of hydrogen, that will be +2, and oxygen being -2 will cancel itself out. So what's supposed to have there is supposed to be +2 and -2. +2 -2 is what? 0. So it cancels itself out. So that's the oxidation and reduction. So I'll send the note so that we can through and get a better understanding of it. But one point you should take note of is the definition of it. Fixed our minds on. These definitions are very important. How to calculate the oxidation number of elements.